Hello guys, I'm back and today I'm with Ms. Behnaz and we'll talk a little bit about chemical engineering drawing. And my name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and it is a pleasure to have Ms. Behnaz here with me today. Thanks a lot for your time, and I know that it's not easy to share time with people to teach them about chemical process engineering, plant design. And before I start, Ms. Behnaz, please present yourself, talk a little bit about you, and now it's your time.
Hi, Jeferson. Thank you very much for inviting me to your live stream. It's very interesting that I can see you here because before this time I have never seen you, and it's my pleasure to be on your channel and talk about chemical process engineering and something related to it. And I really appreciate that you gave me this chance to be on your channel, and I want to say thank you so much.
The pleasure is mine. And just to let you know, we have people from Saudi Arabia, Philippines, and Sandino from Philippines. He is a constant follower. Very nice to have him here. Hamad from India. And the Middle East names sometimes is very hard to me to pronounce that. Okay, I have Abdul from Saudi Arabia, so Kurdistan. It's the first time that I have seen someone from Kurdistan, Safiwan Ahmad. So we have people from many places to be with us today. And the first question is a question that I do to everyone that is my guest, and is how was your transition from when you finished your graduation and you get the first job? How did you prepare yourself to get your first job? Or how was it? Could you share with people that are here with us?
Yes, sure. After my graduation from university, I was hired by a national Iranian oil company as a reservoir engineering, not process engineering. And it was a bit challenging for me, and I started to learn some content regarding reservoir engineering. So I passed some training courses, uh, and it was very interesting for me because it is different from process engineering, and I get familiar with some content like as wellhead drilling, oil and gas reservoir, and something like this. And after a while, when the training courses finished, I noticed that this is not something I want because of the nature of the company. It was a client company, and they have more concentration and more focus on contracts rather than designing and engineering. So I decided to leave that job and start my work as a process engineering in an EPC company, and I have been working for this company over 18 years, and I like this company very well, and I do love my job.
It's not very usual today to have so many years in just one company. How do you think? Why are you? Sorry for my headphone. Okay. Why do you
Okay,
think
no.
that you are so much time in just one company? What is the secret?
For that I'm staying in the same company, you mean?
Yes, there is a
Ah,
secret or not.
yeah, it's a good question. Actually, the atmosphere in this company is very friendly, and a lot of professional experts are working in this company, and it is, to be honest, it is one of the best company in the Middle East. And and sometimes we are very so busy, but it's the nature of the companies in Iran because we have lots of oil and gas reservoir and stocks, and so lots of projects are defined in Iran, and sometimes we are busy. Just this is the only problem we are facing. But I like the atmosphere of my company because of it is very professional, and it has a friendly atmosphere.
It's very important too.
These are the factors that keep me in this company for many years.
The work is important, but people is important also, for sure. And I have seen that you have a bachelor in science and you completed that with honor. You have also a master. And I would like to know what, in your point of view, of course, what is the difference, what you have learned during your master and your degree, and what you have seen in the real life working as a process engineer?
Oh, actually, whatever we learn at university is very important because they are basic and fundamental knowledge, and without them, no process engineer can be successful. But whatever we do in real world and in our job is different from what I have learned at university. And I can give you some example. For example, you want to size a pipe. When you are a student at university, it's very simple. You choose pipeline size and calculate the velocity and pressure loss, and compare it with the criteria and announce the size of the pipe. But when you are working and want to choose a practical pipe, it is a bit different. For example, you need to consider pipe thickness, especially of the pipe, and the nature of the fluid, because sometimes, for example, consider a fluid that has very high viscosity, and you calculate friction factor by a simple equation, but it is not suitable for that fluid. At university, you don't have any worries about if this line is good or not. But when you are facing a real project, you have to choose suitable pipe for that fluid. And another example, for example, heat exchanger designing. For example, shell heat exchanger. At university, we only calculate the area of the transfer. That's it. But when we are designing a heat exchanger, we have to calculate and define all the details. For example, number of tubes, number of baffles, buffet spacing, considering vibration, pressure drop, velocity, and lots of parameters have to be taken into account. So academic knowledge is very important because they are basic knowledge and to know them. Once practical work is different, and there's no way on these facing to work.
You are a process engineer for more than 18 years. And would you say that there is something like, I will get at the top after so many years? It is possible to say that how many years it takes to know everything about your job? Is it possible?
How many years does it take to be a professional, you mean, to be an expert?
Yeah, there's something like that, or yes, can be.
Okay. The answer to this question is very difficult because it takes a long time. Maybe 20 or 30 years after that, you can say I'm a professional process engineer. Even it depends on the person who is working in the process engineer. If a person has good knowledge and work hard and study enough, maybe this time takes maybe less time. It needs for being a professional process engineer. And another problem is that process engineering has many branches. For example, oil refineries, gas treating plants, water treatment, upstream and upstream industries, and petrochemical industries. And it is not only a branch that you can concentrate on it and say, okay, I'm a professional, I know everything. It's very difficult to say that I'm a professional or an expert that knows everything. It takes a long time.
Okay. I can say you that I'm about 14 years or 15 years of experience, but I'm always learning something new. And these days I'm studying again the pressurization system, something like that. And we always find something new to add to our knowledge. So
Yeah, I agree with you. It's the same problem I'm facing all the time.
And the main subject of our presentation is related to cause and effect matrix. But before talking about that, I would like to know with you how is the importance of the engineering drawings for our plan design? And if you can name some of them before we start your presentation.
Before I answer your question, let me say something about our planning. As you know, first we plan to talk about process drawings and especially safeguard diagram and ESP hierarchy diagram, as well as cause and effect diagram. But during my when I was preparing the presentation, I noticed that it is impossible to talk about all of them only in one session, and we agreed to talk about one of them, and we chose cause and effect diagram. And but anyway, I prepared some brief description about different kind of diagrams in process engineering, and we will have a brief description about them on presentation, and after that we can talk about the cognitive diagram.
Okay.
Okay. Do you want me to share my presentation? Or if you have any questions, please let me know.
Yes, I want to, and let me know. You will be able to share this presentation with us after the meeting, or is something that it's only to be live?
No. I will share my file on LinkedIn, and actually maybe I shared that part related to cause and effect diagram, because the brief description or other diagrams is not a comprehensive content. So regarding cause and effect diagram, I will share the file on LinkedIn, and I will appreciate any comments, any questions, and I will answer any question on my LinkedIn. Yeah, I will share it. No worries.
Okay, thank you. And guys, take a look on that. And you can start your presentation. Thanks a lot for preparing a special presentation to us.
Yeah, let me share my screen to you. And okay, Mr. Jefferson, do you have my screen?
Yes, John Lennon screen.
Okay, just for checking. Okay, and mhm. Uh, okay. Uh, as a class, we are going to talk about cosmetic diagram for process plants. And before I start to talk about the cosmetic diagram, I want to have some brief description about different diagrams in process engineering. Process diagrams can be categorized as black flow diagram, process flow diagram, piping and instrumentation diagram, which is PNID, cosmetic diagram, and safeguard diagram, and finally ESD hierarchy diagram. Let's start with black flow diagram. The black flow diagram that you can see on my screen is it's a typical black flow diagram. And each item on black flow diagram is a process unit. The black flow diagram shows feed and products. It means inputs and output, fundamental requirements of the plant, various processes carried within the plant. And as you can see on the screen, there are some red side circles around inputs and outputs. For example, gas well is the feed of the plant in this black flow diagram, and same gas and other gases are other product of the plant. Generally, it gives an overview of the plant. Another diagram is process flow diagram, and it gives more details regarding the plant, and it is a sample of the process flow diagram. If you consider that black flow diagram, the box is available for NGL recovery. The NGL recovery in the box can be expanded in this PFD. And you can see the PFD that has some equipment and other factors, other devices and measures. As you can see, process flow diagram shows many equipment within the process or utility units, the control room, all control rooms and main instruments, process lines between equipment, and operating condition of the instrument equipment. Another diagram is piping and instrument diagram, or PNID, that you can see the person PNID on the screen. If I zoom, you can see more details. And it is an example for compressor PNID, including suction control and air as demonstrated. PNID diagram shows each equipment, and it shows a service description, each piece of equipment, its relevant design condition. It shows all the process and utility lines, and battery limits, and
Yes.
Yeah. And it shows all switches for shutdown of safety and relief plans, rupture these pressure regulating valve, control valves, depressurization valve, or holder valve. All ESDVs, I mean emergency shutdown valves and AO valves, and design pressure and temperature and set point for pressure reading device and check plans, ESD logic, and interlock. All of them are shown on a safeguard flow diagram. And we have another diagram which is called emergency shutdown hierarchy diagram, or ESD hierarchy diagram, or ESD ladder diagram. It is a circle, and if I do the one part, you can see more details. And you can see emergency shutdown logics and the causes that activate ESD and the effect or action of that emergency shutdown. And if you want to see the graphic display of ESD hierarchy diagram, it is something like this on the screen.
Yes.
Yeah. Now, let's see what items to be shown on ESD hierarchy diagram. Actually, ESD hierarchy diagram shows a hierarchy of shutdown level within a plant or a platform. ESD system can be divided in some categories. Some projects started from the level 0 and some projects started from level 1. For example, the first one, the ESD level 1 is a total plant shutdown. ESD level 2 is a partial plant shutdown, and ESD level 3 is a process equipment shutdown. We will have also emergency depressurization as EVP. Shutdown hierarchy diagram is start from ESD level 1, as well as emergency depressurization. And it continues on ESD level 2 and then level 3. Shutdown hierarchy diagram describes the causes that energize each shutdown and effect resulting ESD activation. This was the description of the process diagrams. And before I start cause and effect diagram, I want to explain about some fundamental concepts regarding cause and effect diagram, which is control, monitoring the shutdown of the process plant. On this screen, you can see a sample of control and monitoring on the shutdown of the plant and with a graphic display. Control and monitoring of shutdown systems are designed at the earliest phase of the project by basic licensor designer. As the process moves to project lifecycle, the systems may be developed. Functions that I'm going to present here may differ from one project to another as they are defined by clients and standards in each project. Anyway, the concept represented here is the same. So, what's the systems overview? What kind of systems we have in a plant to monitor divide the systems, we can divide it into major systems, control system and safety system. Another classification is possible, for example, distributed control system or process control system, emergency shutdown system, transportation system, oil and gas system, packaging utensils, basic packaging needs, such as burger maintenance system, machine control system, packaging filtering system, and so on. And sometimes process control system and emergency shutdown system are integrated as the integrated control and safety system, which is called ICSS. It's a slide I describe some different type of package regarding control. Some of them are expandable, and some of them are remote controlled by CSI system of the past, and some of them have their own ECD or control panel located in the ECD, and it is located in instruments technical. And UCD is connected to PCS and EM shutdown system for monitoring control and functions and shutdown. Okay, next.
Ms. Behnaz,
Yeah.
you have talked that depending on the project, you can have this kind of system integrated or splitted, and it depends on the customer requirements or it depends on the standards. How the chemical process engineer should know if he will do an integrated document or it will be a separated one?
Actually, integrated process control, process and safety control are represented by some companies such as Honeywell, and I think some other companies. And it is actually a modern and new technology, and the traditional system was for separate control system and emergency shutdown system. Control system was separated from safety system. Some clients prefer to have these two systems separate from each other, and they choose different vendors for each of them to have more reliability regarding safety of the system. It depends on the client, and it depends on how much money you are going to spend for safety and control system, and it depends on the specifications and standards that's used in each country, and each client wants to be followed. So when a project is awarded by a contractor or by a designer has to follow the customer requirements and the standards, and it is not something that one person or one system can decide about. Maybe some information and some meeting are required to get a result, to know which system is suitable and how much money we are going to spend for the project.
Okay.
As I said, systems are divided to control system and safety system. Let's talk about control system. Control system works at normal condition. It is normal control and monitoring system, and it is done via distributed control system, which is DCS. This system controls the process to produce a good quality product, unsafe product, and keeps all process running within its safety limit. This system is including process control loops, process interlocks, process monitoring, alarms, and switches and push buttons. Now we can concentrate on safety system. Safety system is considered as abnormal, unsafe, or emergency situation. It is designed to protect personnel, equipment, and environment in case of emergency situation or in case of abnormal or upset condition. These actions are done via an emergency shutdown system, which is called ESP. And it is including emergency shutdown and pressurization system and oil and gas detection and alarm system. And that part of packages is connected to the system. ESP indicates oil and gas system. On this screen, you can see an example of safety system. If you see this table, we have low suction gas pressure, and we have gas pressure low here. ESP will be generated, and the result is closing of the valve. Let me zoom the screen. When we have pressure low alarm, and ESP is energized, and the result is the closing of the inlet valve.
So what the matrix does is to show to the who is consulting that if I have, in this case, if I have a very low inlet pressure at the system, the control, the PT and the PI will get that, send it to the PLC or SDCD, and the logic will ask the valve to close. In this case, the tag of the valve is HSV1, right?
Yeah, it is done automatically, and after sensing low suction pressure, an emergency logic will be energized, and the result is closing the valve at inlet. Maybe it has other effects, we will talk about them, but it is a sample. Low suction pressure is an abnormal condition, and we have to protect the system by closing, for example, inlet valve. And this is described in this matrix, and it is shown in PID as well.
Yeah, and
Any question?
in this matrix, you have only valves related to safety, right? Not to control, only to safety. So it is easier to the team identify what how many safety valves for safety system, right? Automatic valve for safety system we have, what they do, what they don't, and something like that. Is that correct?
Yeah, yeah. Yeah, as you told, it is more common that only safety system is described in these charts, not control system. Yeah, it is common that only show the safety system, but depends on the project. In some project, I will explain it in other slides that some projects would like to add interlocks, which is process control system related to process control system in this matrix. But it is preferable that only safety systems are described in this matrix. Yes, you are right.
Okay.
Okay, and next slide. So we have safety system and control system. Process safety system shall be independent and in addition to process control devices, which are used in normal process operation. It means protection measures have different functions from control algorithms. Okay, and here I want to talk about process safety systems documentation. Some common documentations are as specifications of philosophies, cognitive matrix, which is only ESP matrix, or as well in some project it is including interlock matrix or interlock description. Process safety system also has alarm and trip set point lists and diagrams such as ESP hierarchy diagrams and safeguard diagram and logic diagram. It is also included a study report such as spill study or depressurization study. And now we can talk about cause and effect diagram for this introduction. Any question up to here?
No, up to this point, I think not.
Okay, cause and effect diagram. When safety system of a process plan is designed, as we talked about earlier, it is required to evaluate the system. Cause and effect analysis is one of the basic documents for safety analysis of a process plant. What is cause and effect diagram? Cause and effect diagram is presented as a form of matrix and it is used to describe interlocks and shutdowns. Although process interlocks are usually defined with process or distributed control systems, in some projects they are also presented in cause and effect diagram. But some projects we provide separate documents, one for interlock description or interlock table, the other for cause and effect table or cause and effect chart. Cause and effect lists process offset and process responses. Process offset can be manual or automatic, which are shown in rows, and cause and effect diagram. What we prepare cause and effect diagram. Cause and effect diagram is prepared to translate it to proper logic by cosmic system engineer and implemented in shorter logic diagram like logic. The logic will always monitor the plants during operation and those who intended when safety function. We have two categories of cause and effect diagram: process cause and effect diagram and fire and gas cause and effect diagram. As a process engineer, we prepared the first one, process cause and effect diagram. Fire and gas diagram is prepared in firefighting department or loss prevention department, and usually process department does not prepare this document. To the stage of project, we have to prepare cause and effect diagram. Cause and effect matrix is prepared during conceptual and basic stage. During hands-on study and detail engineering, treatment factors and effects will be in my company, process engineering department prefers cause and effect diagram. And so, in some companies categorize cause and effect as a part of process diagram. Some companies consider cause and effect in instruments with deliverables. Anyway, that's specials.
I have seen that besides, or although there is an engineer, it can be the process or instrumentation, there is a responsible to issue the document, but in fact, the development is multidisciplinary, right?
Usually it is multidisciplinary document. For example, if the process department prepares cause and effect diagram, they will send it to instrument department for review and comments. And after review and comments of the instrument department, it will be issued by process engineering department. I mean, it is considered as a document for process deliverables. But in other companies, instrument department prepares this diagram and send it to process engineering department for review and comment, and finally they issue that documents and their deliverables.
Okay.
Yeah, it's better that it is prepared by a multidisciplinary department. Yeah. A person who is going to prepare cause and effect diagram needs to have good knowledge of process as well as control and shutdown of process. How we can prepare a cause and effect diagram for process plants? As we discussed, cause and effect is presented as a form matrix, and the causes are listed in left section, while the effects are listed on top section. Both are described in form of title number with the descriptions and maybe additional information such as PNID number is added. The whole column intersection is marked as cause effects. Cause or process offset, manual or automatic, is including tripping factors such as units, equipment, instruments that will be shut down, stop and start, close and open, after energizing an ESC or an interlock in the transfer case. Items that should be considered and specified in automatic planning. The first one is ESC or interlock takeover. For that, we have to identify ESCs and interlocks apparently, and then insert the takeovers on the chart or two. The second one is causes. We have to identify the causes, for example, process offset or switches and choice, and ESC or an interlock based on section unit and process function. And should be considered in conjunction with penalty and the process description. And then they should specify the takeovers and description of the takeover. The third one is effect. We have to identify the process responses and then specify them, the takeovers and description, and then matrix.
Ms. Behnaz, I know that it depends from project to project, but how many hours if someone needs to fill a data sheet for our estimation, do you think that one should consider? How do you measure that?
You mean you are talking about man-hour that is
Yes.
required for preparing this document? Actually, it depends on the experience of the person who is going to prepare this document, because experienced engineer certainly spends less time than a person who is going to prepare the cause and effect for the first time. But actually, I have to check a document. We have a document in my company that shows the average man-hour for preparing each document, and I don't know, but I think at least it takes 10 hours, 10 hours for each penalty to prepare the cause and effect. This is including drafting and engineering and also checking and supervising the documents. Altogether, maybe it is around 10 hours for each penalty.
Okay, just for a reference.
But I can take it's just my opinion, but we have a chart in my company, and I will check it and tell you the better estimation.
Okay, thank you.
You're welcome. And regarding item 4 penalty drawing numbers, it is optional in some projects. It is mentioned. Actually, it is preferable to have PNID drawing numbers, because it makes it easier to find each item, and it is common to specify PNID numbers for each cause and effect. And there are some other factors that usually are shown on cause and effect diagram. One of them is reset. Reset switches are located in control room and in field, and they have to be considered when designing the system. After all process conditions return to normal operation and ready to restart, the output show the action of the unit or instrument response. I have added a table that lists actions. As you can see, for example, intersection between room and button. If it is specified with A, to move activity. For example, logic, ESP logic, interact logic, energize another logic. It's shown by A. If one is closed, it is shown by C. If it is open, it is shown by O. And the third sub such as SE, SE, T. T is specified as other features or actions that we see instead. This is my favorite I will show this and presentation, let me have an example. Okay, I want to show examples. First, you can see it has some emergency shortcuts, some interrupt. It has transmitters and communication switches. And on this model, first of all, we have to specify ESD logic. For example,
The ESD, it will be described in the cause and effects matrix. Is that correct?
ESC, you mean?
Yes.
ESC, yeah, it's a logic for emergency shutdown. That it is activated by a cause or some causes, and when it is activated, there are one or more effects that should be specified on cause and effect diagram. So, it is ESC 363, and it is known as, let me have an overview of the common diagram. Causes are described in this column, and there is a column for ESC or interlight numbers, and each ESC or each interlight may have one or more causes, which are specified at the left of the table. So the first one, ESC 363, it is the analytic number, and we have to look at the PNID when it is energized. Let me find it. So it is ESC 363, and you can see there is a temperature transmitter that sends the temperature, and it energizes this ESC. Then the temperature temperature reaches low temperature of the pressure of the fluid inside the vessel, it activated ESE 363. Okay?
Okay.
So, in this table, okay, ESE 363 has high temperature. Oh, it is for 6 yeah, it is the high temperature.
From the PNID, we can have some hint or some tips what's happening, right? Because ESD is related to very high temperature because we have a HH, and the ESD 364 is related to low temperature, right?
Exactly. Yeah, exactly. 363 is related to temperature high, and 364 is related to temperature low. So, but the same transmitter is transmitters the temperature. So we have high temperature, and which energizes ESP, and low temperature which energizes another ESP. Okay. Then high temperature in the vessel occurs. The heater should be stopped. The type number is H400 and 400, 100. As you can see, ESD 363 acts on this heater local panel.
Mm-hmm.
And in high temperature, ESD stops the heater from heating the fluid inside the vessel. And it is shown in this part. And it is described in this section. The electron heater will be stopped by energizing ESC.
So it will, if the temperature is too high, it will stop or turn off the heater, right?
Yeah, exactly. And when we have lower temperature, the pump should be stopped because not to pump the fluid to the downstream and cold fluid to the downstream. Look at the PNID. ESD 364 acts on the pump motor and it stops the pump from pumping the fluid, as you can see here.
It stops the pumping.
Yeah. If you have a note here, note 8, the pump will be stopped when the fluid temperature is below 5 degrees centigrade. This is limitation. Okay. We have another ESC here, and it is 359, which is generated by sensing the level of the vessel. Then low level alarm is triggered. Okay. And when we have low alarm inside the vessel, this ESC is energized and it acts on the pump to start the pump. Yeah?
Okay.
And it is specified again in the table. learn. The liquid level in the drum is energized PSC, and the activation of the PSC effect on the plant to a site. If the project wants to interact to be described in this table, we can continually interact, and we have some interact that one of them is, let's check, for example, when we have high liquid level inside the drum, when we have high liquid level inside the drum, an interact with the activated, and this interact is called the pump. And then we have no liquid level in the pump, that is called separation. These two interacts were used for establishing effects.
Very nice, very nice. And this one and was one of the very technical presentation, and this is very nice because usually the graduated and even the fresh engineers have not is not familiar with this kind of document. And to be sincere, in my project, I will never. I have seen this one or two times in a hydrogen plant, but as much of my work was in air separation, I'm not so familiar with the cause effect matrix because we do everything in the control, and it's very nice to get familiar because when you start a new job, if your employer or if the interviewer asks you about cause and effect matrix, you can remember about the Ms. Behnaz presentation, and she will let this file available in her LinkedIn. So very nice.
You're welcome. Just the last page is sample of interlife description. It is when we are not going to present in quadratic diagram, we prepared an interlife description, like something like this, or sometimes it is presented as descriptive text, and it is sample of interlife description. I hope the information presented here is good, and for your follower on LinkedIn and anyone who is going to have basic knowledge and very quick knowledge regarding cause and effect. And I hope it is useful and informative. Let me back to you. Let me back to you. And
Stop sharing.
Stop sharing and switch on my camera. Can you see me?
Not yet. Okay, now it's okay. Yes. And we have some we have many people following us here, and we are going to the end of this presentation, but we have a very special audience here. Vijay Sarati following us, and he said that your presentation was excellent. The presentation was scripted well with covering the basic documentation required. First, process flow diagram, PNID, safety guarding philosophy, and ESD hierarchy. Waiting PowerPoint copy on LinkedIn. So if he approved it, everyone will approve as well.
It it would be a good idea if we can have other sessions for explaining about ESC hierarchy diagram, safeguarding diagram, and I think each of them needs one video streamline and or video section session. And yeah, if in future, if it's possible with you that we have other sessions for that kind of diagrams. Yeah.
Ms. Behnaz, just before we start finish this presentation, you are already about 18 years old, experience in process engineering. And what is the next step? There is any other next step that you are planning to your career?
Next step, actually, I would like to teach whatever I have learned during these years. And so I started to write a book 2 or 3 years ago regarding player network sizing and sizing and designing, including scenarios applicable to relieving studies. And but unfortunately, I couldn't finish it. Only I wrote 300 pages of that book, and 600 pages is left. And I wish I could find some time to finish it. Maybe I hope I can publish it in Persian and English as well. And it is one of my wishes that I have that I can want to complete that book.
Okay, and before
the
I
next I mean that the next step is teaching and sharing the knowledge you have learned during these years.
That's very nice, because I think that we get in a point of our career that it's very nice to have the feedback that we are helping people. And with the internet, it's easier to do that these days, because we can share typing on LinkedIn, for example, having a blog or a YouTube channel, and wherever. There are many options to do that, and I'm pretty sure that we will be able to do that. In fact, you are already doing. And before I let you give the final message to the audience, and I asked you to do this presentation here with me because let me tell you a secret. When I did the list for the 5 top in the end of the last year, I almost added your name there, and I thought a lot. And the only reason that I didn't add that was because you do great materials, but you don't do that frequently. And one of my let's say my criteria was the consistency. But you have very great materials. The tutorials that you have related to vertical pumps is really great. And that was the only reason, because I saw few posts there. But of course, I'm not saying that it was a mistake, but probably today I would change my mind and add you to the list. And in the end of this year, I will do another one, and for sure you will be there. And Ms. Behnaz, thanks a lot for your acceptance. And it was a pleasure to be with you here. And I believe, in my point of view, that this technical presentation was very great. And please give your final words to the audience.
Final words. First of all, all, let me thank you so much for your nice work. Actually, have I don't have enough time and don't have free time to produce such documents and publish on LinkedIn. And actually, it is one of my it is my wishes that I can find some time to generate this kind of documents. I have lots of handwriting that I want to publish on social media. I hope I can find more time, or I can manage my time better. And the last word maybe is if a junior engineer or a graduated person wants to be successful, it needs time, effort, hard working, and study, and especially when they are going to generate a document, it's better to gather enough information, different sample in different projects, not only one procedure, one project, because the information maybe differs from one project to another. And that's it. And thank you so much for inviting me into this interview. That was great to see you. You are one of the best person on LinkedIn because you are so generous. You share whatever you know, you share your knowledge unconditionally. And it's so nice to see that some people like you are lead on the earth. You know, it's very good that I see some people like you, and thank you for you and your followers for watching this interview, and any questions and comments if you require on my LinkedIn, certainly.
Okay, so guys, see you soon in the next Saturday.
Thank you.
Bye bye, Ms. Behnaz.
Bye bye.